quite a lot in the last class. One interesting thing I just wanted to mention you. So it is first we write down one for mixture and summation I equals to 1 to C mu I dmi dH equals to dTs plus bdP plus summation I equals to 1 to C mu I dmi dA equals to minus STP minus PdV summation I equals to 1 to C mu I dI dG equals to minus SDT plus VdP summation I equals to 1 to C mu I dI. This is for the with the extensive variables, and you can write the same thing for the specific variables. The specific variable du PdS minus PdV plus J equals to 1 to C minus 1 mu J star dHJ, right? dH equals to PdS plus VdP plus J equals to 1 to C minus 1 mu J star dHJ. dA equals to minus SDT minus PdV plus J equals to 1 to C minus 1 mu J star dHJ, and dG equals to minus SDT plus VdP plus J equals to 1 to C minus 1 mu J star dHJ. Okay. One thing you can notice that for this expression, this is everything is clear. That is dou H by dou P at S n bar. What is that? Capital V, am I correct? Which is not equal to dou H dou P S x bar. Am I correct? How do we prove that? Dou U by dou S V n bar is nothing but dou small u by dou S small v x bar. But this is the case, and it happens for this, this two, and here. This is very no problem. For this kind of case, you will see this will never happen. This part I wanted to mention that, and it's quite obvious why it will not happen, because dou H dou P S n bar, you can write this as dou P n H hat S n bar, which you can write as since n is constant coming out dou H by dou P small s and x bar. Okay, and this is equals to capital V. So what will actually happen? V by n, which is nothing but small v, which is dou H by dou P S x bar. So still you can write. Okay. So that's the way you can actually look into it. That's why this is so. This is the way you can actually formulate. And this part I missed, I think, for the pure substance. But okay, never. This late is always there. It's better than never. So you can see the similar kind of thing will happen for dA, dou A by dou P at fixed V n bar is nothing but dou small a by not equals to dou A by dou small v, dou small t at fixed V x bar. So same way you can actually extend the situation, right? So now you can just that's why you can see that this both are not equal. And last class we have seen the relationship between the chemical potential and generalized chemical potential. That also we have discussed, and we have found that mu I is the chemical potential. If you subtract the CH component chemical potential, you will get generalized chemical potential of the atom. Okay, if you subtract CH component chemical potential from that mu I, you get mu I star. So, and also we have proved from the fundamental principle that summation j equals to 1 to c mu j xj equals to u minus ts plus pv equals to 0. This is already proved. And this was further verified from Euler's theorem at the end. This was further verified from Euler's theorem. Which is st plus b into minus p plus I equals to 1 to c mu I ni equals to. Correct? From Euler's theorem. Homogeneous function. We have proved it is homogeneous function. U is SBN1 into NC. We have proved that if you put lambda times, lambda will be there, so the function is homogeneous. If the function is homogeneous, you can actually have Euler's theorem and the order here is order and so on. Euler's theorem always 1. And from here, it is possible to have Gibbs-Duhem relationship. Please look at your notes and find out what is the relationship. The same way you can go for Gibbs-Duhem relationship and tell me the answer. The Gibbs-Duhem relationship. The Gibbs-Duhem relationship will be obtained from the same, from the similar way. Gibbs-Duhem relationship. Gibbs-Duhem relationship can be obtained from a similar way. So what will you do that? You just take derivative here, which is SDT plus TdS, similarly minus 3dB minus VdB, similarly mu I dni plus ni dB. And you know du equal to TdS plus Vd minus VdB plus summation mu I dni. And if you just cancel it out and you get a quick expression for the Gibbs-Duhem relationship. Anybody can give me the answer? Anybody can give me the expression for the? Yes, sir. SDT minus VdP plus summation I equals to 1 to CS ni d mu I equals to 0. That's the Gibbs-Duhem relationship. And similarly, you can obtain this kind of Gibbs-Duhem relationship for all these equations and all these equations. So for all this, for each equation, there is associated Gibbs-Duhem relationship. For each equation, there is associated Gibbs-Duhem relationship. Sometimes it may be important, sometimes, and in Gibbs-Duhem relationship, of course, we don't use much, but sometimes you feel like using that for some situations. So you'll be using Gibbs-Duhem relationship very often in mixture thermodynamics. That I will demonstrate in subsequent lectures. So this part is quite clear, and we all proved it. This all mu i's are same, and this all mu j's are same. So you all know that. So basically, initially mu j star h, mu j star a, mu j star g. Similarly, it's mu I h, mu I a, mu I g, and we proved that they are all same. So far it is going in accord with the pure substance thermodynamics. So pure substance and mixture, they behave almost similar way except the extra terms. Otherwise, they are behaving in a very nice fashion. Okay, so we'll catch up the Euler's theorem and proceed further. So if you look at U equals to U hat SB N1 to NC, H equals to H hat, which is S minus P N1 to NC, A equals to A hat, which is T V N1 to NC, and G equals to G hat T minus P N1 to NC. This minus you can actually omit. This function of A minus X, you can also write this as a function of X. And for this place, for this part, we have applied Euler's theorem. And when you apply Euler's theorem, you should also cross-verify from the fundamental derivative principle what we have done. The reverse derivative, and we have found that the Euler's theorem is valid, is also benchmarked by the fundamental derivative derivation. So we have found St minus Bp plus summation I equals to 1 to C mu I Ni equals to. And if you divide by n, you have to put in terms of specific variable, which is St minus Bp plus I equals to 1 to C mu I Xi equals to. Okay, and from here it is quite obvious coming as G equals to U plus Pb minus Ts. Yes, is it correct? And this is equal to G. This already is equal to G, and this is actually was it was proved, and in fact I didn't talk about the linear transformation. Linear transformation, if you talk about, of course, if you talk about the partial and full everything, you can then say linear transformation. So this kind of expressions we are talking about linear transformation, it can be verified, and I simply ignored for the brevity. So okay, so we have G equals to U plus Pb minus Ts. Fine. So for the brevity, it is C minus 1. Of course not. I was correct. Please go back to derivative derivation. Please go back to derivative derivation. When I give mu I plus mu equals to mu C plus mu I star, there actually I proved it's G summation I equals to 1 to C mu I Xi equals to U plus Pb minus Cs. I am not writing the combined first and second law of thermodynamics. I am not writing. I will soon introduce something called partial molar property, and there I will show that summation I equals to 1 to C will be there. And it's quite obvious. You just divide by n. Divide by n. Why the C minus 1? Don't follow blindly. See everything mathematics. Everything should come from mathematics. Okay? Correct? We should not be C minus 1, should be C. And that's correct. Okay? So G equals to plus Pb minus Ts we have actually found. And now one thing actually I would like to show here from this equation number. This is my equation number A. I won't put it here. This equation number A. From equation A, number A, we have found that Ts equals plus summation I equals to 1 to C mu I in I equals to 2 plus Pb equals to H. Right? From equation A. From equation A, one can also write minus Pb summation I equals to 1 to C mu I in I equals to U minus Ts equals to A. From equation A, one can also write summation I equals to 1 to C mu I in I equals to U plus Pb minus Ts equals to G. Quite often, we, in our experimental system, we put constant temperature and pressure. We keep constant temperature and pressure. So, in that case, the last expression, what I wrote, it is very, very important. What I wrote, the last expression, G equals to summation I equals to 1 to C, mu I means what? Dou G by dou Ni, Tp Nj, J not equals to I, Dn. Right? This mu. Of course, you can argue on other things, but I am just talking about this particular thing because I need something for this in this context. This mind. What I am saying that G is the function of Tp in 1 to NC. If I say my system at constant temperature and pressure, at constant temperature and pressure, what will be my G? G will be G hat N1 to NC. So in that case I can say that if G is N1 to NC, I can still write Euler's theorem, right? I can still write Euler's theorem. I think yes, from here. I can still write Euler's theorem. Summation Euler's theorem is what? Summation xi dou f by dou xi equals to f. N is the order of the thing, ours is 1. And this is for our case Tp xj where j not equals to 1. Okay? Or you can write here Ni is better because we are talking in terms of at constant temperature pressure, and this happens to be the chemical potential. This happens to be the chemical potential. Okay. Now my question is, when you look at H and A, H is what is this mu I for H? One hand please. What's the mu I for H? Just a hand, otherwise I don't know. Yes. That's all, right? Dou H by dou n and no other constants. That's the thing I don't like. You don't feel the thermodynamics. You know that something you're telling wrong, but you don't care. Dou H by dou Ni at constant. What? Tp. SB. NJ. J not equals to 1. So you don't talk all those. If I don't talk, you'll say, oh, sorry, stitching back. I'm sorry, I'm again referring that because I deliver my best when I sweat it out. When you talk, you don't care. You just talk like that. You don't talk minus, you don't talk anything. But anyway, so, and you cannot see this is a homogeneous function with respect to, because I want to have this kind of expression. And this G is directed to chemical potential. So my question is, what I'm asked, actually, let me pose the question in this way. I wrote G equals to summation mu I Ni. It is correct, it has been proved. My question is, can I write H equals to summation I equals to 1 to C mu I Ni? Can I write A equals to summation I equals to 1 to C mu I Ni? Answer is no. So from the Euler's theorem, if I want to write this kind of expression, what should I write? Analogous to this, what should I write? You get my question? This is proved. I want to write H this kind of fashion. What will be the, this won't be mu I, it will be something else. What it should be? That means what I am saying that my objective is G, H, A, U. I want to write as a function which is T, P, N1 to NC. And if Tp is constant, you can write this as constant. So it will be nothing but N1 to NC. So what will be my U? What will be my H? What will be my A? And G, of course, you know that. Summation I equals to 1 to C dou G by dou Ni Tp Nj J not equals to Y Ni. What should be the expression for U, H and A? I have given the answer in the board. I have given the answer in the board. If you look at the board, you can get the answer. Answer is there in the board. Answer is there in the board. If I say that, you can see that answer is there. I can write out a summation I equals to 1 to C summation I equals to 1 to C, summation I equals to 1 to C. Similar expression also you can write. What is the expression? It is there in the board. Apply Euler's theorem. Apply Euler's theorem. Can you say that? Yes.
So 2H by
What is which what you are talking about?
Sir, H.
H, not you. Talk about you.
So that should be dou U by dou Ni.
Dou U by dou Ni.
At constant TP Nj not equal to I.
Exactly. Thank you very much. Very good. Into Ni. That's it. Thank you. So it is dou H by dou Ni Tp Nj J not equals to I Ni. This is dou A by dou Ni Tp Nj J not equals to I. Remember that these are not chemical potential. Chemical potential is with respect to U, how you define? Dou U dou Ni is V N J not equals to I. It is Tp. H is not the chemical potential because we define dou H by dou Ni is P N J not equals to I. This you cannot define because the chemical potential is dou A by dou Ni P T P N J T V N J not equals to I Ni. Okay, and these are known as, this quantity is known as something. What is this quantity? Partial molar property. This is known as partial molar. I write this way. This is known as partial molar property. So our expression is U equals to, for a mixture, if you want to, I equals to 1 to C, Ni U I bar, H equals to summation I equals to 1 to C, Ni H I bar, A equals to summation I equals to 1 to C, Ni A I bar, G equals to summation I equals to 1 to C, Ni G I bar. Similarly, if I say volume, how much? Summation I equals to 1 to C, Ni Vi bar, and but Vi bar is nothing but dou V dou Ni Tp Nj not equals to any property in mixture. In contrast, for the pure substance, this is the mixture. For the pure substance, what we are writing? For the pure, this is mixture. Pure substance, U equals to Nu, H equals to NH, A equals to Na, G equals to Ng, capital V equals to Nv. These are called the specific properties, and these are the partial molar properties. This is the difference. The first difference we are seeing it here, that if I want to calculate the total internal energy, these are all extensive properties. This is specific property. This is specific property. This is also specific property for unit mole. You can see that. Okay. So the specific property, it is there for the pure substance. For the multi-component substance, the partial molar property, which is defined as, for example, Ui bar is defined as rate of change of internal energy with respect to change of number of molecules, ith number of molecules, if other temperature, pressure, other molecules are kept constant. In that case, that property is known as the partial internal energy for the ith component. In that case, it is known as partial internal energy. So for any property, the rate of change of, so partial molar property, any property which is partial molar property, which can be defined as dou A by dou Ni Tp Nj J not equals to I. The rate of change of that property with respect to the rate of change of the ith molecule while the temperature, pressure and number of other molecules kept constant is known as the partial molar property of the ith component. Okay? Clear on the partial molar property. Okay, so let's take down the problem in the assignment. Assignment number 3, problem number 7. Second page. The partial molar volume of ethanol in a 60 mole % ethanol water solution is 5.75 to 10 to the power -5 meter cube per mole. The density of the mixture is 849.4 kilogram per meter cube. Calculate the partial molar volume of water in the mixture. Calculate the partial. So there are two systems. So the system is very straightforward. Only two. There is a minimum number of components in the mixture. One means the pure substance. Two things are there. So the partial molar volume of, so it is talking about partial molar volume Bi bar. Only they have given the expression in the board. If you look at. So molar mass of ethanol. Molar mass of ethanol is how much? Ethanol is C2H5OH equals to how much kg per mole? C2H5 per mole how much kg? What is equal to 3 kg? 46 10 to the power minus 3 kg per mole. If I say per kilomole, you can say 46 kg. Okay. Molar mass of water, there are two components. I am saying this by component number 1. Water, which is how much? 18 into 10 to the power minus 3 kg per mole. Component number 2. Okay. Molar mass of 60 mole % of ethanol mixture. Total mass, molar mass, capital M, I am saying, of 60 mole % ethanol water system. 34.8 is not the correct answer. 34.8? Yes, that's the way. That's the complete answer. So it is 0.6 to 10, 46 into 10 to the power minus 3 plus 0.4 into 80 to 10 to the power minus 3 kg per mole, and it is coming around 34.8 10 to the power minus 3 kg per mole. Molar volume of the mixture. Molar volume of the mixture. Molar volume of the mixture. Small v. You know the mass. The density of the mixture is given. Mass by density equals to volume, right? The density of the mass mixture is given. Is 849.4 kg per meter cube, right? So how much is the molar volume of the mixture? Pardon? Minus? No units. That's what I'm telling you. You guys, even if I die, you won't tell the unit. That's the thing. Anybody? Meter cube per how much is the answer? 40.9 to the minus 6. 10 to the minus 6 meter cube per mole. You have to get V1 bar and V2 bar, right? The partial molar property. So, what we know about now they apply the formula. Now we have to apply the formula, which is capital V summation I equals to 1 to C Ni Vi bar. Sorry, small vi bar. And small v equals to summation I equals to 1 to C xi vi bar. Small v is what? Capital V by N. Ni by N is xi. Xi vi bar. Okay. Which is x1 v1 bar plus x2 v2. x1 v1 bar plus x2 v2 bar. V1 bar, partial molar property of ethanol. So V bar is given, or V1 bar is given. What is given? V1 bar is given. So how much is V2 bar? V1 bar is given. How much is V2 bar? V is also there. 40.9 10 to minus 6 meter cube per mole. V is also there. How much is V2 bar? Mole fraction is given x1, x2, 0.6. V2 bar is how much? Yes, 16 into minus 6 minus 16 into minus 6 meter cube per mole. I move to the next problem. It's very easy. You can actually go back home and do it. Problem number. It is the same extension 7b. It is required to prepare 3 meter cube of a 16 mole percent ethanol water mixture. Determine the volumes of ethanol water to be mixed in order to prepare the required solution. The total number of volume is given. 3 meter cube of the total volume I want. Okay, my B1 bar, B2 bar is now, they are now obtained. Small b is also there, 40.9, then plus minus 6 meter per mole. So determine the volume. So this is a very practical problem. You can do it in the beaker, you can do it at in the beaker in the experimental lab. And because partial molar property is something you can easily find out. You can easily find out the partial molar property. That is not that difficult to find out. Partial molar property can easily find, easily found. Okay. So number of moles of solution required. Number of moles of solution required. How much mole? 3 meter cube by total mole. What is per meter? What is mole per meter cube? What is that? Mole per meter cube? What meter cube per mole? 40.9 minus 6 meter cube per mole, right? So if you divide meter cube by meter cube per mole, you will get mole, number of moles. How much mole is coming? This is school level problem actually. This is very easy. If you know physical chemistry, you can do that. Nothing is there, thermodynamics here. This is all moles business. Number of moles for the solution required. How much it is? Total number of moles is 3 meter cube, right? What is the volume? What is the volume? 40.9 10 to the power minus 6 per mole. Volume is this much meter cube per mole. So how much is the total number of moles? It is 73349.6 mole. Correct? Yes. So number of moles, the number of ethanol solution, mole number of ethanol in solution, mole number of ethanol in solution, which is N1 equals to N into X1. This is my N, number of moles, into 0.6. How much it is coming? 44,009.8 mole. Volume of pure ethanol required. Volume of pure C2H5OH required, which is N1. Tell me, what is the formula? Volume of pure C2H5 required. Now, how much it will be required? You have to have 3 meter cube of the solution, 60% basis. What is the formula for the pure C2H5 required? That much volume you have to add. You have to make a solution, right? You have the cylinder, you have measuring cylinder. You have the solution. Based on this calculation, you add it up to have the mixture. What is the formula for the volume of pure C2H5 required? N1 B1 bar, right? N1 B1 bar. That's why our formula is capital B is nothing but N1 Ni Bi bar. So each one is the N1 B1 bar is the volume for the first component. N2 B2 bar is the volume for the second component. N3 B3 bar is the second volume of second component. So third component, so on. So how much is coming? 2.548 meter cube. 2.548 meter cube. And same thing, and you can actually N2 B2 bar you can actually calculate by the same procedure. You can get NX2, and if once you know the NX2, you know N2, and then N2 B2 bar is the volume required for the what other compound. Okay. So now by now you have got a proper understanding of the partial molar property. So before getting into much further on this, I just wanted to quickly brush up I forgot to talk about the Maxwell relationship, right? You have the Maxwell relationship of pure substance. Remember the Maxwell relationship? Please go back home and try to derive the Maxwell relationship for this multi-component substance, and I can tell you that the Maxwell relationship will be also valid for the multi-components of the substance the same way. I don't want to derive it because just like the same thing, just ditto, you have to do it ditto. Okay. Now we'll be moving to the partial molar properties. As I said that we frequently use the Gibbs-Durham relationship and all, and let's proceed further on this. And one thing actually here in this last problem we found that partial molar property is given in the question. How to determine partial molar property? Can you determine the laboratory scale? That means after my class you can go to the lab and determine the partial molar property. If you can do it, you can see thermodynamics by hand. Okay? You can experience thermodynamics by hand. So we'll proceed further in the laboratory scale how to determine partial molar properties. A specific volume you know. You have a total volume, you have the number of moles, divide number of moles, you get specific volume. Where is it determined? If I have ethyl alcohol, I am saying my volume is 3 liter cube. We immediately calculate number of moles. Okay? How much then alcohol is there? You take the weight. Okay? How much is this? Number of moles is this much. So I have this specific volume. How to calculate this partial molar property? If a mixture like ethanol, water, and ethanol, water, or methanol, you all are there. I want to have specific volume for each component, which I call as partial molar property. Partial molar volume. The specific volume of each component you don't say thermodynamics, we call as partial molar volume. How to calculate partial molar volume? So let's talk about partial molar properties. So we talk about partial molar properties and determination. How to determine? Okay. So capital V, we now saw that V, E, P, N1 to N. This we can write this as NV, TP, X1 to Xc minus. Because if it is function of N1 to Nc, we can say that X1 to Xc minus 1 because Xc can be obtained by 1 minus summation, right? Because 1 is constant. Because here this N is the value. That's why we have same thing already. So when we talk about the VI bar, the partial molar property, which is defined as rho V, rho Ni, Tp, Nj, J not equals to. We can write this as. So now I am particularly working on this topic because I want to determine the partial molar property. And for that purpose, we need to have some mathematical treatment so that we are amenable to have the laboratory experiment. So we have rho Ni, Nv at which is Tp X1 to Xc minus. Which is Tp Nj, J not equals to. Okay, we proceed to obtain Vi bar. Similar you can actually do for any partial molar property. You want to talk about Ui bar, Hi bar, Gi bar, anything you can do the same. I am just doing for the partial molar property. Because volume you can easily measure in the experiment. If you want to talk about the partial molar property of the Gibbs energy, partial Gibbs energy, okay, that is difficult to measure in the experiment in the lab. The only thing you can measure the partial molar volume, because you can measure this cylindrical and all those things, but with the cylindrical thing about the partial internal energy and all those things, you cannot measure. So it is partial enthalpy also you can measure, but this is pretty difficult. Okay, so Vi bar. So there are two things: ddx of uv, u dvdx plus v dx. N is there. Okay. So before going to that, I just want to proceed. Summation P equals to 1 to C or you can say j equals to 1 to c, no problem. Nj into b e p x1 to xc minus 1 EP Nj j not equals to 1. Okay. Yep. So this you can take derivative. If you take derivative, what will actually happen? Dou ni of summation j equals to 1 to c nj. You have done it earlier in the class. This is not the new thing. Last class you have done it, last Friday. How much it is? Just raise the hand and tell me. Not double. Dou ni. So first I will take derivative with respect to b is constant. So since b is constant, I can write this as t p x1 to xc minus 1 into dou ni of summation j equals to 1 c of nj. If you don't understand I and j, pick up some number, dou n 5 and 10 components. Just this is the way you will do that. If you don't get really confused, you put 5, 10, 3, 5 like that. 3 is the particular number, 5 is the number of components. What did you get? That is the way I remember. That is the way I remember. That is the way I remember. That means I am saying that dou n 3 of this component. How much you will get? Just one hand please. Not you. Not you. I am pure on result. I'll ask you if I wanted an answer from anybody. I am surprised that people don't care. 41 people in the class. Only 3 or 4 people raising the hand. They will don't know it also. Answer? Do you know the answer? That I am asking yes or no. Then next question is I'll ask the answer. You know the answer? Okay. Who else? I am just looking at somebody else who can raise the hand and give me the answer. Nobody else? I am really surprised. I am asking for dou ni of summation j equals to 1 to c nj or nothing but n. How much is the answer? How much is the answer? Any hands please? Yes? 1. And to get 1 we will take so much. Okay, plus n dou v by dou ni, which is t p nj, j not equals to 1. And this you can write as, and this b is, remember that this b is nothing but b hat tp x1 to xc minus 1. Okay. So next step you can write btp x1 to xc minus 1 into 1. 1 you cannot. How to evaluate this dou v by dou n? tp and j not equals to 1. I want to express everything in terms of the small quantity, that means x. Yes?
Sir, we can aim into dou v by dou xj into dxj by
Dou v by dou xj into
summation.
Yes, I just will come summation j equals to
c minus
1
into dou xj by dou l.
Okay. Correct? This is, we have T, P, N, J not equals to 1. Dou v by dou xj you can just keep it. Dou xj by dou ni. When you talk about dou xj by dou ni, this of course your n is variable, right? Your n is variable. Dou xj by dou ni, your n is variable. What is dou xj dou ni? What is xj? Nj by n. Proceed. Dou xj by dou ni. We have done it earlier. You have done it in last Friday. If you have your class notes, you can actually find out. Dou xj by dou ni. Delta ij by n. Delta ij by n. Delta ij by n minus xij xj by n. Correct? Okay. So what you do get? Finally, Vi bar equals to V plus N summation j equals to 1 to C minus 1 dou V dou Xj delta Ij minus Xj N by N What happened? I'm not doing anything, I'm just copying what you said. Next step, Vi bar equals to V delta Ij, and as I said, if I say delta Ij, you can actually pull up the summation. Only one term will be there because this equals to 1 if I equals to j. Okay? So that means this will together will have dou V by dou Xi. Correct? Yes. Only one term will be there. If you are not familiar, you put j equals c equals to say 2, 3, whatever, and you can do it. We have done it earlier. Dou V by dou Xi minus j equals to 1 to c minus 1 dou V dou Xj Xj Xj. This is valid for I not equals to c. This is valid for I not equals to c. Because this expression we have I equals to 1 to c minus 1. I am saying if I equals to c, what will happen? If I equals to c, this will not be valid. If I equals to c, here I is not constant, I is flexible. 1 to c minus 1. If I put stick there equals to c, what will be my Vi bar? V plus something. Please raise the hand and give me the answer. Please hand, one hand please. At least one hand. If I equals to c, what will you get? If I equals to c, what will you get? Yes, Rahul. Minus, because this term will go. Because I equals to c means this will never have 1, j, because j will be varying up to c minus 1. So c minus 1 maximum, and all the time it will be 0. This term will go up. We'll have only v minus summation xj dou V dou Xj. Is that clear? Yes? Yes or no? Yes? Okay. So j equals to 1 to c minus 1 xj dou V dou Xj. Okay. So for all I, we have Vi bar, which is V plus 1 minus delta Ic dou V dou Xj minus j equals to 1 to c minus 1 xj dou V dou Xj. Thanks for your kind attention. Okay, so we'll discuss from here the next class how to determine